problem, the graph y equals x squared. I'm going to start with the basic form of the graph. The y equals x squared give us the parabola graph. The x equals 0 is the y-axis. The y equals 1 is the horizontal line about the y-axis. So this is the axis of revolution. Okay. Put them all together. The parabola graph and the other color for x equals 0 and y equals 1. And I believe we look at the region in the first quadrant. So, okay, quadrant number 1. If you would add it, this part like quadrant 1, what we are interested in your note, that would be great. So we just look at the right side of the region. Okay, from this we can see the region bounded by these two lines and the curve. And the left end will be 0. The right end here, where the y equals x squared meet the line y equals 1, going to be at the point x equals 1. We can do it by hand real quick without, doing too much of the computation. The axis of revolution is is the y-axis. So we put the arrow here that show us we're going to rotate this region about the y-axis. So this is the axis of revolution. Now, when you do the cross-section or the slicing technique, you do perpendicular to the axis of revolution. That means when you do the slide, you do the one perpendicular to the y-axis. So when you identify this way, that means the location at that point is the location or the position y. Okay, and the thickness is the dy or the change in y, because you're gonna move the y up and down or the slice up and down in the y direction. Okay, so we identify the thickness as the delta y or the change in y, which is the same as dy. The position y will be bounded, will be from the lowest y, which is 0, to the highest y or the maximum y, which is 1. So this is the interval of integration. Okay, next, once you rotate it, you're gonna form the solid of revolution as this way. So gonna be kind of a ball. Okay. So one cross section, so you're gonna form a disc. And that disc has the radius. So this is the radius r, which is the measurement from the right graph to the left graph. Okay. Everything will be with respect to y for this situation, because the thickness is the change in y. Okay, so the radius from the right end, which is based on the graph y equals x squared. I'm going to put a note here. We make a list, the radius, the right function. I'm going to put a note as the right function minus the left function. The right function as y equals x squared. We know it's based on the y, or with respect to y. We're going to rewrite this as x equals square root y. Okay, so square root y. And the left function would be the equation x equals 0, so minus 0, the left function. So this is the right function, and this is the left function. Or the radius comes out as square root y. Okay, got all the prep work done. Now put together to find the volume. The volume is pi integral, the radius squared multiplied by the thickness. For our case, the integral, lower limit 0, upper limit 1, the radius is square root y squared, the thickness is dy. Simplify one more time to get pi times integral from 0 to 1. Square root y squared, that's y with respect to y. Antiderivative to get y squared over 2 multiplied by pi, and then evaluate from 0 to 1. And it comes out as very nice and clean answer as pi over 2.